All right, Hess's law. Hess's law allows us to use the fact that enthalpy is a state function to find the enthalpies of reactions based on the enthalpies of reactions. Enthalpies of reactions we don't know based on enthalpies of reactions we know. So it's a state function. We can add and manipulate reactions. So we have a reaction and we have the enthalpy for it. Okay. So we can multiply, divide, and reverse a reaction. Those are the manipulations we can do. So, and it's possible to have fractions because we're talking about moles, not individual atoms. So, if we were to double this reaction, then we would double the enthalpy. If we were to have this reaction, we would have the enthalpy. And if we reverse the reaction, we multiply the enthalpy by -1. So whatever manipulation you do to the reaction, you do the same manipulation to the enthalpy. So multiply, multiply, divide, divide. Those are really easy. And then reverse, multiply by -1. All right. So if we have this reaction and we have this reaction, what we can do is we can sum these reactants. Okay. So I have NO on the products and NO on the reactants, so it's going to cancel 1 to 1. So 2 NOs cancel with 2 NOs, 1 to 1. And then I can sum the reaction. So I've got 1 N2 and 2 O2s, and I'm getting 2 NO2s. And the delta H is just going to be the sum of the two enthalpies of the reaction. So 181 plus -113, or plus 68 kilojoules. That is Hess's law. The tricky part of Hess's law is getting the reaction into the order you want it to. So let's look at a trickier example. All right, calculate delta H for the reaction C2H4 plus H2 giving me C2H6, given the following thermodynamic data. 1, C2H4 plus 3O2 gives me 2CO2 and 2H2O with this enthalpy. 2, 2C2H6 plus 7O2s gives me 4CO2 plus 6H2Os, so that gives me that enthalpy. And 2H2 plus O2 gives me 2H2O with that enthalpy. Okay, so the best way to evaluate is to say, okay, I know what I need and I know what side I need it on. So I need 1 C2H4, and I look at equation 1, and look, I've got 1 C2H4. And that's the only place I see that in the reaction, so that has to be like that. So I'm going to leave that one normal. I'm just going to put it down here. I need 1 C2H6 on the product side. So I not only have to reverse this reaction, but I also have to have it. And so I'll do the same thing to the enthalpy. So reverse the enthalpy, -1, and then have it. And I need 1 H2 on the reactant side. So I'm just going to have 3. So remember, I'm going to also have the enthalpy. And so now I need to sum these up and make sure that everything cancels to give me the reaction I want. So 2 CO2s on both sides. That's easy to see how that cancels. Here, we actually have 2 waters here and 1 water here, which is 3. So 3 waters on the left and 1, 2, 3 waters on the right. Those are going to cancel out. And then if I look, I have 3 O2s and half an O2, which is a total. So 3 is equal to 6 over 2. So I have a total of 7 halves O2. And over here, I have 7 halves O2. So the O2s actually cancel perfectly. So then when I sum it up, I've got 1 ethene plus H2 giving me 1 ethane. And so then the enthalpy, I literally just add these together and you get -136.8 kilojoules. So just take it one step at a time. And you don't have to do them in order, right? You can put them in any order you want to. All right, so let's practice. Calculate delta H for the following reaction. 4 ammonia plus 5 oxygen gives you 4 NO plus 6 H2O using this thermodynamic data. So take a moment and work this. All right, so we can see this one. So I need 4. Let's start with this. I need 4 ammonia. So this reaction, I'm going to reverse and double. So 4 NH3 yielding 2N2 plus 6H2. And delta H is going to be equal to -91.8 times 2. Which is -183.6. Okay. All right, so that takes care of that. Then the O2, I've got O2. So here I'm seeing that I have oxygen in multiple equations, so I'm going to leave that one alone for now. But NO is only in this equation, so I need 4 on the product side. So I've got 2 on the product side, so I'm going to double this. So 2N2 plus 2O2 gives me 4NO. Okay, so that's my 4NO. And delta H is going to be equal to 361, negative 361 kilojoules. Boy, I'm running out of space. Okay. And then finally the waters. I need 6 waters. So I have waters on the right side, but I need 3 times as much. So I'm going to triple this. So 6H2 plus 3O2 gives me 6H2O. Delta H is going to be equal to negative 483.6 times 3, or negative 1450.8. And so now we're going to look. Okay, 4 ammonia doesn't cancel with anything, so I'm going to get 4 ammonia. Okay, I have oxygens on the left, but on the right, I have 2 plus 3 is 5 oxygens. 6H2 cancels with 6H2. Okay, I have 2N2 cancels with 2N2. Okay, and then over here on this side, I've got 4 NOs and I've got 6 waters. So, and oh look, that's the reaction I was looking for. So then I add all these enthalpies together. So, negative 183.6 and 361 and 1150.8. Oh, sorry, this should be positive 361 because I reversed it. Whoops. Gives you 973.4 kilojoules. So that's all Hess's law is. It's just manipulating reactions to get the one you want. There's just, remember, if you flip the reaction, you need to apply a negative sign.